My name is Artur, and today I would like to tell you a little bit about UI profiling in our team. I think that most of us work in teams not so big, like maybe 5 or 10 developers, and we are one of these teams. I work in a startup, we have a limited amount of time to implement a feature, and because it's a startup, we need to implement features very fast. Otherwise, we'll just run out of money, and we'll have to find another job. And because of this, often, what do people say about their features? It works, kind of. And we ran into the same problem and made it a little bit better, so it works well. And let's see how did we do it. The example will be on the simple app that we've developed. It was Wing messaging, and today we'll cover a little bit things about how Android renders views, how can you understand if you have some problems or you don't have, what are the layout issues that you can run into, what is the overdraw problem, and how to understand if it works well on devices of your final users. And the goal of this talk is not to make like super UI profilers from you. You will not be probably a guru of profiling. However, if after this talk you will get to your project and run some tools and trying to understand like if you are doing well or not, then I will think that my goal was accomplished. OK, the speed of UI. What do people actually see? First of all, it's this very important number. Please pay attention. 86% of people remove apps if they look slow and right after the first installment. And it means that if you are doing a bad job in the first time, probably you will not have a second chance. And that's a very important thing to remember. So what do the people see? First of all, it's some kind of feedback. If I press something, I want to see that something happens. And from Android Lollipop, it's pretty good in this thing that we have ripple effect. So a person pressed, a person sees something, and that's OK. Second, it's a question of actual timings. If I press something, I see a loader, but this loader like works for several seconds, probably I won't be very happy. And the last one that we will discover today is frames per second. It shows you how smooth your app works, like overall. And probably in case if your app works in 10 frames per second, you will be able to understand it even without any tools at all, because it will be bad. 24 frames per second is a little bit better thing, because starting from this point, people will think that, oh, it's continuous movement, so it will be more or less smooth. However, many people think that 60 FPS, that's a number that we should be counted for. And why? Because there were different researches about how do people perceive video. And in case from 24 till 60 FPS, you still see like a small slight difference between how it looks like. And after 60 FPS, people's eyes usually don't see like any difference at all. So 60 FPS. And sometimes you can see 0 FPS. And that's not a bug, that's not a problem actually, because Android is a pretty smart thing, and it understands that if you are not changing anything, it will not show you any new screens, any new frames. So that might be totally OK too. And here we come to a number of 16 milliseconds. Please raise hands. Who knows what is this about? 16 milliseconds. About 10%. Oh, great. So it looks like many of you will have some additional knowledge today. So 16 milliseconds, it's a simple thing. So if you want to show 60 frames each second, so you have about 16 and 6 milliseconds to be able to render this frame and show it to user. And what happens in 16 milliseconds? Actually, each 16 milliseconds, we have an event called vsync from Android system. And vsync, it's a thing that shows that, oh, you need to produce a new frame. And previously, there could be a problem that, for example, in time when some device shows one frame, another one is already ready, and you see like half of this frame, half of that frame. And this thing is not possible in Android because we use a technology called double buffering. And one buffer is on the screen, another one gets built. And if the another one is not ready, they won't be swapped, they won't be changed. So you won't have this problem that you have like half of one and half of another. Only transactional full one. And what happens? There is a class called choreographer, and each time when it gets this vsync event from Android, it starts to work with user input, first of all, touches, if touch start or ended, or something like this. It shows you a new animation, not shows, but calculates a new animation, calculates new values required for animations, creates some view, renders them, and that's actually it. And to be able to do it faster, there was a things called display list that were introduced in Android 3. And actually, that's just a caching of already existing views, so you don't have to create them again and again. And that's rendering cache. It exists one for each view, doesn't contain any logic, so it works pretty fast. And that's great that you can do a whole operations on the whole list if you enable hardware acceleration. And that's how works all these animate view properties. Probably most of you have used them, for example, to animate some alpha or something like this. And instead of working on the separate views, this will work on the display list overall, so it will be more performant. And the good thing that it can be moved to a render thread. Probably you have heard that starting from Android Lollipop, we have a separate render thread. And because of this render thread, our animations work better, because previously they had to work in CPU, in the main thread, and in case if you're doing something other in main thread, you have problems. And now, if main thread already prepared so-called changes, I mean these transitions, then this transition will just change some special variables due to render thread, and main thread will be able to produce its job and make its job. So display lists look like this. It's like draw rect. It will be of such color, blah, 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 blah. And again, so we have 16 milliseconds. We have these 16 milliseconds to be able to build a frame. And how it happens. We build a frame, we sync, we draw it. We build a frame, we sync, we draw it. We build a frame, and on vsync we wasn't ready. So what will happen? Probably many of you saw this line that, oh, 100 frames drop or something like this. And this happens in case if you are not able to produce a new frame in that amount of time. What are the reasons? Usually, it's something that you are doing on your main thread. For example, input-output, like database access, or maybe some calculations if you are working in maps and trying to calculate some path or solving some NP problem there, and so on. And another one is layout issues. Maybe you have deep hierarchy. Maybe you have transparency issues, because when you use transparency, Android has to first render the background, then understand like, oh, I should apply a transparency here, then like unite both of these layers, so it happens in several stages actually, and it's quite expensive operation. And you can just have lots of views or overdraw problems. And today we'll talk about these things, complexities of layouts. We'll use several tools, and there are some that you can see here. Please raise hand if you worked with all of them, at least once for educational or some other reasons. OK, 1, 2, 3. That's cool. So first of all, we need to understand if we have a problem at all. Because if we don't have it, why should we solve it? And the simplest thing to this is to use GFX profiler, GPU profiling. You can turn it on in Android developer settings, and you will have some bars, horizontal line. And this horizontal line below, it shows you 16 millisecond threshold. If all of your lines, all of your bars are below it, it means that you are safe. That's great. If you are going above, you should think about something. And what do these bars mean? Depending on the color, they will show you how much time you spent doing some work in main thread, or how much time you spent working on measuring, layout, and all these issues with your views, or how much time you spent in ondraw, bitmaps, and refreshing finally these display lists and moving them to screen. And the good thing with this tool is that you can use it with other apps too. For example, with your competitors. Here you can see a screenshot from Telegram, from WhatsApp. And what does these colors mean? For example, in our app, we saw a lot of orange color. That means that for some reason swapping GPU buffers took too much. And some dark green colors that meant that we use something in main thread. And later I will show you how we solve some of these problems. However, visualization is good, but it's bad if you don't have exact numbers. And if you want to get some numbers, it's better to use a tool called gfxinfo. You can use it using adb command, and you will get a lot of different numbers. Yeah, of course, you can get some perfect charts from it, but in my opinion, that's not the point. And the more important thing is that you can get aggregated data from this command. So it will show you how many frames were rendered, how long do that take, how many junky frames did you have. And junky frame is a frame, again, that was not been able to be shown in 16 milliseconds. And the good thing with this that you can combine it with your tests, for example, espresso tests or other end-to-end tests. And after each run of your tests, you can run this command. And then you will see how you're improving, or maybe otherwise. And that's a very important thing. You can find, or we can discuss after this talk, how can you do this. And that's interesting that nothing is perfect. And you would say, you would think that WhatsApp, with their like tens or hundreds of Android developers, should do a pretty good job, yeah? And I saw that sometimes there is almost a wall of this thing that, I mean, of the times when you are not able to get under the 16 milliseconds. And this is the Telegram. And actually, I've opened an SMS app in Pixel, on my Pixel, that's pretty strong in my opinion. And I saw the same problem. OK, who can guess what unites all these three screens? What's like similarity between them? Why can it happen? Three screens. No guesses? I have some stickers. Winner will get sticker. Excuse me? Yeah, some UI element. It's RecyclerView, input text. OK, you won. So all of these things have, 1 second. Hey. So all of these things have an input text, edit text. And for some reason, there is a bug in Android that shows that, oh, like, I can't work on it. And the funny thing, another funny thing is that in Telegram, you will see this edit text in several places. It might be black, it might be white, but for some reason, on the right screen, you see that there is like no such problem. And I don't know why, but we decided that it's not a problem for us, because when you start scrolling the app, actually it goes to normal, and you don't have this problem. And you have this problem only if user does nothing, and this pointer just like appears and disappears. So we decided that, OK, let it be updated on 30 milliseconds, we don't care. OK, and now what gets measured? Only then we could manage this. And to be able to measure it better, we can use such tool as HierarchyViewer. And HierarchyViewer looks approximately like this. So you will have some tree, you will have some properties of views. But more importantly, you can run it and press on profile node. When you press profile node, you will get some colored circles, basically. And these colored circles, they will tell you how long does it take to measure, layout, and draw a particular view. And depending on the color, you will see that, oh, this view is updated or something like this in faster than 50% or slower, or maybe if it's red, it's one of the worst ones, and probably you should pay attention to it. And you should remember that everything is relative. And for example, here you see a view that's rendered in half a millisecond, and it actually contains a text, it actually contains an image view, so it's not so bad, and you can't do anything actually with it, but it's red. And here you can see a green one that is rendered in 20 milliseconds. And if you remember, we have 16 milliseconds for the whole screen. But here we spend 20 milliseconds on only part of it. So that means that we should probably work on it. And that's an important thing. And once, when we developed the app, everything worked fine. I mean, we tested it, we sent messages to each other, and it was fine. Then we shipped it to our management, and what we get? Hey, it's slow. And I hope you won't hear the same from your management, but we did. So what did we do? First of all, we opened that GPU profiler and saw that we don't do like anything complicated in main thread. And for some reasons, our view on draw and on layout took too much. So we understood that, oh, that's probably some problem with layouts. We opened HierarchyViewer, and what have we seen? That our screen is rendered in 40 milliseconds. That's pretty bad. But the strange thing was that it showed that we have 300 views on this screen. I mean, it's like 10 messages, 5 avatars, and you have 300 views. And we were like, what? So, OK, we understood and tried to swap a little bit and watched at a smaller tree that you can see in a preview. And understood that we have a lot of different repetitions. Pressing on each node, we understood we have several chats simultaneously on the same screen. I mean, usually I speak with one person, I need one chat. So why in the hell I have 5 here? OK. Then we swiped a little bit to the left, to the right, and got 500 views and like some enormous amount of time to render. And it became like obvious. So it was fixed just to be rendered in 6 milliseconds. And what was the issue? The issue was that we started to use controller and conductor, I mean, library. It's a thing, so you can work without fragments, without all this complicated lifecycle, to create some encapsulated things based on views. And instead of changing one controller to another, our newcomer pushed one on top of another. So if we'll talk about fragments, it's the same as using fragment transaction add instead of fragment transaction replace. And I mean, could we find this problem? Probably yes. But the question is that it's already slipped through our initial code review, and we have like pretty big code base, and to be able to understand like in which exactly point this happened wrong, it could take a lot of time. And here we just opened a tool, and it was obvious. Of course, like not every problem will be solved so easily, but at least you should know where can you look at. In addition, it will show you some redundant containers. If you have this line of different containers, one inside another, and only one child, so probably something is not needed here. And actually, there is even Android performance link that shows you that you have empty frame layout, that you can change into merge check, and so on. Why does it matter? Because most layouts require several passes to be able to lay out and position all their views inside. And if you have a nested hierarchy, you can have a lot of different requests that will run one after another without actual reason. And yeah, now it's a little bit simpler if you use constraint layout and trying to make it flat and so on. But anyway, we fixed it. And what have we seen? Actually nothing. Our data showed more or less the same data. Why I say more or less? Because each time when you run this profile node, you will get a slightly different results. So there will be some dispersion, and actually sometimes there will be even outliers. And here you can see 2 consequent run of this profile node. And first of them shows that it's about like 40 milliseconds, and another shows that it was built in 100 milliseconds. And why? Just because tool works like this, and if you press like 10 times, sometimes it will be in like dispersion, and sometimes it will be outlier. And because of this, you have to press several times to understand what is the actual amount, and shouldn't trust the first one. And thing that actually helped us a little bit is a Viewstub. Please raise your hands who has already worked with a Viewstub. About 5–6%. OK, cool. So that's a special view that is not shown to the user until you call either setVisibility, either inflate of it. You show that, oh, and, I need to inflate this layout, and when you will do this, this layout will be inflated. And yeah, it looks a little bit like a dynamic. You can say that, oh, I will just create it from code. But the thing is that here you can have all the layouts in one place, and not in a way that something is an XML file, something is in code, and you are trying to understand, oh, how was this screen built at all? Second, it's easier to set its position because it's visible in preview, and especially with constraint layout. I don't know what's about you, but I in particular don't like to make all these constraints in code because they're quite worthy. Another thing is that you should test your app on slower devices. Previously, several years ago, many people complained that, oh, Android Studio emulator, it's so slow, and so on. But now it's not the case, actually. And on my MacBook, this view was rendered in 11 milliseconds. And we have like hundreds of thousands of users who use Samsung J2. It's like a budget Samsung phone. And even the simpler screen was rendered in 100 milliseconds there. And then you understand that, oh, OK, I need to buy this device, and I need to test on it if I want to get like real results that my real users see. And actually, you should know how your tools work. For example, here, we see that on draw took about, I've especially added sleep command into on draw. So what should you expect from HierarchyViewer? That it will tell you that, OK, on draw is about 1 second, yeah? Please raise your hands who thinks that on draw will show a little bit more than a second here. 1. OK. Who thinks that this thing will show a little bit less than a second, maybe 990 or so? Nobody. OK. Who thinks something other? OK. How much?
I think it's not in milliseconds, but I'm guessing.
Not in milliseconds. OK, and there? 1.5 seconds. OK, yeah, I will not run with micro probably. So nobody won, because it was drawn less than in 1 millisecond. I mean, sleep for a second, but draw less than a millisecond. And why? Because time is actually a little bit different. And we are living with a wall clock time that runs like continuously. And there is actually a thread time that is counted only when thread does something. So in case if you are doing something in your own draw, for example, going to background and trying to take something from your database, you will not see this issue in your hierarchy viewer, and you should be aware of it. And if you, for some reason, decide to calculate Fibonacci number, for example, here, then yeah, you will see that you're in trouble. And just for curiosity, if you want to see how the real display list works, you can use HierarchyViewer to show a display list. OK, conclusions. 10 measurements, 10 different results. Red is not always bad. And it's important to be able to make all of your optimizations on numbers. And the biggest, I think, drawback of this tool is that metrics can be taken only in a manual way, and it's not possible to automate them. And unfortunately, probably this won't be changed as HierarchyViewer is not longer developed. Because Android Studio suggests us to use Layout Inspector, but unfortunately it doesn't have any profiling means at all, for now at least. So let's hope that they will add it somewhere, and HierarchyViewer still works with nowadays apps, if you need it. Another thing that you can run into it is Overdraw. Again, you can turn it on in debug panel, developer panel, I mean, and you will see some colors in your app. And depending on the color, you will understand how much time a particular pixel was overdrawn. I mean, it was drawn once, twice, 4 times? OK. And see, here, for example, you can see that background is green, and that means that each pixel was drawn at least 3 times. Actually, even 4, because there is a decor view, and decor view is not counted in these calculations. But anyway, to be able to fix it, it's again, we can use a hierarchy viewer to extract layers to Photoshop file. Then we can use any image editor to show this Photoshop file. And for example, here we see that we have one background and another white background. Like, that's totally pointless. And why it's happened? Because now you often have an activity. Inside an activity, you have a fragment. Inside the fragment, you can have a custom view. And you don't always know where you have a background or where you don't. And because of this, you can run into this situation. If you will spend like just a little amount of time, it's quite easy to fix it, usually just removing a couple of backgrounds. And you can see still a red one on the top. That's an avatar view. So we had our own avatar views that was like red in overdraw, implemented in 4 layers. And it took 4 milliseconds to be drawn. Is it like more or is it less? I mean, small amount. Anyway, let's see. Then we understood that, oh, OK, let's see what can we do. We found a library from a company. For this library, there was a post describing the solution. And I think I will be right if I say you that if you see a couple of libraries, and for one of them you have a post describing how it works and why it was created, then probably you will stick with the one with this post. And guys tell that, oh, it's so cool. We are working with Canvas directly without any like redundant things, and so on. Overdraw is blue. That means that it was like rewritten only one time for each pixel. But it was rendered for 50 milliseconds per each avatar. Why? That's another question. But again, as I told you, we are a startup, so we didn't have time to work with it. And we just decided that, OK, our bicycle is good enough. Sometimes ready solutions will be better. Sometimes they may be worse. And again, like it's maybe Captain Obvious, but guys and girls and women, please measure, and measurements matter. If you want to play with it a little bit, you can use a Scalpel from Jake Wharton. So instead of using Photoshop, you will see approximately do you have some overdraw or you don't. And so to conclude, overdraw is easy to check. It's easy to solve. But for us, it looked like it's not so important. And actually, I've been to Google I/O this year, and I've spoken with Roman Guy, and he told me that, yeah, nowadays fonts are quite stronger comparing to what it happened like to be previously. But anyway, if you have some problem and you don't know why it works like this, you could try to solve overdraw, but it's not guaranteed to bring you like real effects, only in some rare cases. And after you shipped everything, so now you know that, oh, OK, my app works well. I even tested it on some devices. But how can you understand how it works on all of your users? For example, we have about 1 million users. So they have plenty different types of fonts. Maybe many of them are from China. And that would be pretty hard if we haven't had such tools as Android Vitals from Android. And you can see, for example, how many frozen frames you have. You can see what is the average rendering time for your app, and you can divide it into and filter it into different types of your app, into different operation systems, into different fonts, and you can get actually a lot of different information. And the good thing that all of this is for free. You just use your Google, how it's named? Google libraries, Google support libraries, and this information will be calculated for you, starting on fonts from Android 7 and higher. And sometimes you can even find some strange things here. For example, here we see that there are 2 maximums. And after this thing, we started to investigate why some of our screens are so slow, because it looks like there is a normal distribution and there is another one. And this is how we find that issue with the cursor, because only on one screen with this cursor we had this like frame drop. And actually it appeared to be not a problem, but anyway your data is a little bit, how it's named, dirty. But OK, we can live with it. And to sum up, because of timing restrictions, I haven't told you about SysTrace, about TraceView, and actually starting from Android 3.2, both of these tools are included into Android Studio, and you can easily use them. Before you had to like run a special command line tool to be able to work with SysTrace, for example, and now it's become like much simpler. And there is a talk from Google I/O that I suggest you to look like, because it will help you to understand when you should use one or another. And actually, when you are trying to understand again what happens wrong exactly, these 2 tools might be very useful, because you can instrument your code and see how fast or how slow it actually works. And again, if you're interested in it, I will be here till the end of conference, so we can discuss it. And I found this quote that at Instagram, their engineers spent about a year just to make their app working better, smoother, faster, and all of this stuff. Of course, I understand that not every company can spend so much resources. I mean, both time and engineering like minds and work. But anyway, in my opinion, you at least have to understand where you are now. Yeah. So maybe it's not the time to make some optimizations, but at least you should understand if you have to think about it at all. And that's it. Thank you for your attention. As usual, we are hiring, so if you want to like find some remote job, you can contact me. And that's my contact details. Thank you for your attention.
OK, so maybe repeating, what was the deal with that edit text and its cursor? Why was it suddenly such a problem? And do you even fix it?
So yeah, that looks like a problem inside Android. And in that time when it like appears and disappears, for some reason there is a frame drop. It happens like in 20 milliseconds or so. There is actually even a bug reported in Google bug reporting tool. But they told that, oh, OK, maybe we will fix it somewhere. And I don't know, it was like half a year or a year ago. And it looks like it's still here. Yeah, as I told you before, I think that we don't have to remove focus from it, because in case if a person starts to swipe or to do like anything when it's important to have high performance, it looks like they have some tools that stop it, so your frame rate will be OK. And the only case when you like have this problem is this idling state when nothing happens and only this cursor works. And probably if you will return, remove focus from it, probably it will be not so visible for the user that there is a cursor and it was done with some point. So I wouldn't suggest to do this.
Do you have experience with constraint layout? If it helps, if it improves
Yeah, we haven't run like a separate tests in particular with constraint layout. Of course, we use it as, first of all, Google suggested, and second, it's often easier to make some complicated layouts using it. But we haven't run any like special test actually. But a friend of mine working in a big company that has a lot of engineers, they told that yeah, they run some experiments and it looks like it works with a similar speed as a relative layout. And again, that in complex layouts it helped them, probably because of this deep hierarchy thing that was discussed earlier. Thank you. And yeah, by the way, please pass these 2 stickers to the people who asked something. Do you have other questions? Was it? Oh, okay. There is one more question.
Yes, I have a question regarding the automatization of this process.
Please closer.
I have a question regarding the automatization of this process regarding, for example, integrate with continuous integration server. You show us how to deal with the problem of the performance manually. Can we automate this process?
Yeah, first of all, and that thing that I mentioned, but only shortly, about gfxinfo. There are, again, we can discuss it after the talk, but there are already several tools that are ready and implemented in Kotlin and Java that you can use to integrate it into your CI and just run this gfxinfo after you've run some tests. So basically, you clear the data, you run test, afterwards you run this gfxinfo, and you see, again, how many frames were there, how many junky frames were there, and so on. And in this case, you can see it on in your CI. Are you getting better or worse in this case? And that's a very important thing.
OK, thank you.
So there are many like Android devices which are so different in terms of performance, and you want to make like super cool animations. So do you consider like disabling some animations or something like this for these slower devices?
Yeah, of course. First of all, you have to understand if this animation is like really performs worse on some devices. And as for us, it was the simplest thing. We just bought like a lot of different fonts that our users use, so we could do it like on hand and understand if it actually works well or not. So then we just turned on. Basing on Android version, we just used like one code path or another to show animation or not to show. And actually, in our case, it's a little bit simpler because now we have API 23 as a minimal SDK, and maybe we'll go to 24 because of some stuff. And because of this, we have more or less good devices, so it's not the biggest issue. Thank you.